Hi.
Yay! 4.4, part 1. So this should have been done already in class, but it's a little review to go over anyway. So the graphs of sine and cosine are called periodic because they repeat every 2 pi, because that's one revolution around a circle. So here are some properties that we went over in class. The main things I want you to notice are 0, max, 0, min, and 0. And over here we have max, 0, min, 0, max. These are the only 5 points you need to know. So if I would trace the sine graph, I can literally move it over here and it will match exactly up. So you see the green is overlapping. This is called a horizontal translation of the sine graph. Yeah, so the general form of sine and cosine are here as follows. We're going to go through each letter individually. All right, so looking at the unit circle, we're going to go ahead and we're going to graph sine and cosine. Okay, so for y, we're looking at the sine. For y, we're looking at sine, so sine is our y value. So I'm just going to highlight all of my y values. So at 0 degrees, I have a y value of 0. At pi over 2, I have a y value of 1. At pi, I have a y value of 0. And at 3 pi over 2, I have a y value of -1. So here's -1. And then at 2 pi, I'm back at 0. So we go 0 max, 0 min, 0. And that's just our sine graph. Now for cosine, we're going to look at the x value. So I'm just using my quadrantal angles. These are the same points I start with every single time. All right, so I'm going to start with a x. Let's see, I'm starting with my x at 0 degrees. Okay, so that's sine is 1. And then at pi over 2, our x value is 0. At pi, my x value is -1. Go back to 0 at 3 pi over 2 and back to 1 at 2 pi. So here, I'm starting at max, and I go to 0, down to my minimum, back up to 0, and then back up to my max value. So these are the 5 points we're going to use every single time. Okay, the factor A provides a vertical dilation of the graphs of sine and cosine as follows. So if the absolute value of A, the number in front of cosine and sine, is larger than 1, this means there's going to be a larger amplitude. And if it's less than 1, it means there's going to be a smaller amplitude. So notice I'm doing absolute value, because if it's a negative in front, it's going to be a reflection. It will be flipping. So here, the difference is I'm going from a 1 amplitude to a 4. All right, so let's go ahead and let's draw out our axes. All right, so first I'm going to draw my sine function. So the 5 points for sine, right, we're using 0 degrees. So 0 radians, pi over 2 radians, pi, 3 pi over 2, and 2 pi. These are the 5 points we're going to use. So if we look at the y values there, the y value at 0 radians, so this is like our angle, and this is the y coordinate because we're dealing with sine, and sine is y. So it goes 0, 1, 0, -1, 0. So it goes 0 max, 0 min, 0. Okay. Oops, I forgot to label these. That's 1, 2, -1, -2. 0 max, 0 min, 0. But remember we have to do 2 periods, so I'm going to keep going. 0 max, 0 min, 0. All right, connect. We have this nice wave. Now the difference is I'm going to multiply every single y value by 4. That's all this does. This 4 in front is the amplitude. It's going to cause it to stretch by a factor of 4. So multiply each of these by 4. Our new y values are 0, 4, 0, -4, and 0. So I'm multiplying 0 times 0, 1 times 4, 0 times 4, -1 times 4, oops, -1 times 4, 0 times 4, 1 times 4, etc. I'm just stretching it out by a factor of 4, so it's much bigger amplitude. So this is my g of x, and the green was my f of x. So notice that I have an amplitude of 4 versus before my amplitude was 1. Now let's check out the next one. So once again, I'm only going to be multiplying every single value by a number. So this is just a amplitude of a half. It's just crunching it vertically. So before, my sine function used to be 0 max, 0 min, 0 max, 0 min, 0. So this is my f of x. Now I'm going to multiply every single term by 1/2. So now 0 times a half is 0, half, 0, min at negative a half, 0, max, 0, min, 0. So here we go. So notice g of x is just, I'm crunching my green closer to the x-axis on both sides. Now, this one's a little more difficult because we have cosine. So cosine starts at a max of 1 and then 0, down to a min of negative 1, 0, up to a max of 1, and then we just repeat max, 0, min, 0, max. And the numbers we're getting, the numbers I'm using for my max and min values come from the unit circle. So we're looking at the x, okay, so the x and y of cosine of x. Remember, this is the x coordinate on unit circle. So we're still going to be using the same 0 radians, pi over 2, pi, 3 pi over 2, and 2 pi. These are just our quadrantal angles. But this time, instead of looking at the y coordinates at each of those, we're going to look at the x coordinates. So the x coordinate, we start at max of 1, then 0, negative 1, 0, 1. So we start at a max, go to 0, hit up our min, 0, and then go back to our max. So when I multiply all those numbers by 2, my new values are 2, 0, negative 2, 0, 2. Start 2, 0, negative 2, 0, 2, 0, negative 2, 0, 2. Right, this is my g of x, and the red is my f of x. So that's it. Okay, graphs with reflections are on the horizontal axis. When the constant a is negative, the graph is reflected around the x-axis. So this is a little more difficult, right? Because we always want to know, are we stretching? Are we compressing? So we take the absolute value of a. If this is larger than 1, it's going to be a stretch. And it is, because 2 is larger than 1. All this negative does is flip. So the amplitude is still 2. Amplitude is a distance, and distance is always positive. All right, so I'm going to write out my cosine again. So cosine starts at a max, 0, min, 0, max, 0, min, 0, max. Perfect. But this time when I graph the reflection, it's also going to be multiplied by negative 2. Sorry, when I graph g of x, is going to be reflected across the x-axis and stretch out by a factor of 2. So more or less, I'm multiplying every single y value by negative 2. So first I'm going to take 1 times negative 2 is negative 2. And then 0 times anything 0. Negative 1 times negative 2 is going to be positive 2. Then 0, go down to a min, negative 2. So min 0, min 0, max 0, min, back to 0, up to a max, 0, and min. Perfect. Okay. Now, what I want to do is I want to, let's see, the amplitude is still going to be 1/2. Oops, let me come back up here. So this amplitude is 2. It doesn't matter which side I look at. For the green, the amplitude is still 2, although I'm multiplying by negative 2. Alright, so I'm going to draw my sine of x. We always have the same angles we're going to be using. So for sine, 0 max, 0 min, 0 max, 0 min, 0. So I labeled my x-axis in such a way that every single vertical line, I'm going to have a point on it. Right, that's the way I labeled it. Alright, so this is my f of x. And then if I want to take g of x, multiply every single thing by negative 1/2. So all of my zeros are still going to be the same. The difference is I'm flipping it across and I'm shrinking it by a factor of 1/2. Flip it across and shrink it by a factor of 1/2. Alright, so I took my old y value, so for instance right here, I take 1, and I multiply by negative 1/2, so it gives me a y value of negative 1/2, which I graphed down here. So the red is my g of x. All right, so periods. Period is going to be 2 pi over the absolute value of b. And b is the number in front of x. So for example 3, I'm going to take 2 pi over absolute value of 2, because this is my b. So if I have 2 pi over 2, that's just going to be a period of pi. Now, this 3 is going to be my b, so if I take 2 pi over 3, oh, that's it. It's just going to be 2 pi over 3. Remember, it's the number in front of x, not in front of the whole like sine or trig function. So 2 pi over 1/2, and if I take 2 pi and divide by 1/2, it's the same thing as multiplying by the reciprocal. So this is going to be a period of 4 pi. Now let's take 1/5. 2 pi divided by 1/5. So dividing by 1/5 is the same thing as multiplying by the reciprocal of 5 over 1. So the period is going to be 10 pi. And 0.25 is the same thing as 1/4. So instead of dividing by 1/4, I can multiply by the reciprocal of 4 over 1. This is a period of 8 pi. And then here I have 2 pi over my b, which is 3 pi. Turns out pi's cancel out, and my period is just going to be 2/3. So that's it for the first lesson.